So we discussed in the beginning of this unit that one of the most important practical use of linear algebra is finding the solution of linear system of equations. So let's first define what is a linear system of equation. So let me write down the definition first. So a linear system of m equations in, say, n unknowns is a set of equations of the form a11 x1 plus a12 x2 plus dot 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 plus a1n xn is equal to b1, and the second equation can be written as a21 x1 plus a22 x2 plus dot 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 plus a2n xn is equal to b2, and so on and so forth. We can write down the mth equation as a m1 x1 plus a m2 x2 plus dot 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 plus a mn xn is equal to bm. All right, and in the linear system of equations, the term ajk, so the terms a11 a11 a12 a1n a21 and all these guys, so the terms ajk, where j is equal to 1 to j can take a value from 1 to till j can take a value from 1 till m, and k can take a value from 1 to one of the values from 1 to till n. So these ajk's, they are known as the coefficients of the linear system of equations, and the coefficients are always given, so they are given numbers. All right, and in the same vein, bi's, all the bi where I can vary from 1 to m, so all the bi's are also given and they are known numbers. In case if all the bi's are 0, so let's say if all the bi's are 0 for all I equal to 1 2 till m, 1 2 3 till m, the linear system of equations is known as a homogeneous system. It's known as a homogeneous system. And if one of the bi is not equal to 0, then the linear system of equations is known as a non-homogeneous system. A non-homogeneous system. So throwing some definitions at you, and we'll find use for them later on in this course. The solution is a set of numbers x1 x2 till xn that satisfy all the m equations. So x1 x2 till xn need to satisfy all these m equations. All right, and the solution vector is a vector x whose components constitute a solution of the linear system. So let me just write. So x will be equal to x1 x2 till dot 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 xn, and it would be amiss if I do not discuss that why this form or why this system of equations is known as linear system of equation. And the reason is that because the power of x's, or the power of unknowns, that is x1 x2 till xn, it's always 1. It's not 2, it's not 3, it's not a fractional power of x. So it's always 1. So that's why the system is called a linear system of equation. So for example, if you were to consider this linear system, let's say 2x1 plus let's say 2x1 plus 3x2 is equal to 5, and let's say 9x1 minus x2 is equal to, let's say, 0. So this is a linear system in 2 equations and 2 unknowns. All right, but let's consider something else. So let's say if you write 2x1 square plus 3x2 is equal to 5 and 9x1 minus x2 is equal to 0. Now this is not a linear system of equations, because the power of x1 in the first equation is 2, it's not 1. So this will not be a linear system. Alright, so that's all I had to discuss in this lecture. I'll see you folks in the next lecture.